let's have a look at the important formulas in financial maths. So what we have interest, which we've covered in the last two lessons. We have simple interest and we have compound interest. And interest is about things increasing in value. And we also spoke a little bit about inflation, right? So we spoke a little bit about inflation. And inflation was related to positive interest or interest. Let me quickly, there we go. There we go. Okay, so inflation also got factored in to the last two lessons. Give me a thumbs up if that all sounds familiar so far. Give me a thumbs down if that sounds unfamiliar to you. Okay, and welcome to Ganlin. I see who's joined us. Okay. Cool. All right, then also in the previous lesson, we spoke a little bit about something called the effective interest rate. And the nominal and the effective interest rate are combined using that formula, although I wrote it in this form. I wrote it I effective is equal to 1 plus I nom over m to the power of m minus 1. Now that looks a bit weird, but the m is just like, if it's per month, the m would be 12. If it's per quarter, the m would be 4. So this is just basically the way that we break it up. The nominal rate is the rate per annum normally, and the effective rate is the rate that includes the effect of the compound interest. But we'll come back to that in a later lesson. Then, what is the main focus for this week? The main focus for this week is depreciation, or negative interest, or the loss of value. And we have something called simple depreciation, which looks a lot like the simple interest formula, except there's a minus. And then we have compound depreciation, and some textbooks call this reducing balance depreciation, or RBD. Give me a thumbs up if you've heard of reducing balance depreciation or compound depreciation. It's just like compound interest, except there's a negative. Okay, lots of students have not heard of this compound depreciation. And so I need to make sure I go nice and slowly, which I will, so don't worry. But I just want to point out, look at how similar they are in the formulas. The only difference is it's negatives here, not positives. Okay, but we'll get going with this in today's lesson. So let's have a look at the definition. It says, decay or depreciation is when a quantity decreases by a percentage of the amount present. For example, your assets or machinery lose value through age and use. So when you buy a brand new iPhone, if you're lucky enough to buy a brand new iPhone, or someone gets you an iPhone, or a Samsung or whatever phone, maybe the phone costs 8,000 Rand when you buy it. However, after 2 years, you will never get that 8,000 Rand back. You will always get less because of depreciation. It loses value. If you're lucky, maybe you'll get 3,000 Rand back after 2 years. So what we can say here is we've lost 5,000 Rands worth of value. Okay, so that's the basic idea of depreciation. But how we describe how it loses value year by year is going to have more to do with the formulas. So let's have a look at this example. It says simple decay or depreciation. So we've got this formula, A equals P, 1 minus NI. I would prefer to write that like this, A equals P, 1 minus IN. And all I want you to do is see if you can identify which value is the A, which value is the P, which value is the, and I want to see, can you try and figure out what the answer to this is using what you know from last week? So I'll give you 60 seconds to try, and then I will do it for you, but let's just see how it goes. Now, a car worth 120,000, is that going to be the A value or the P value? What do we think? I think that this is actually going to be the P value because that's what you start with. The A value is what I need to get in the end. The I value is 0.12, and the N value is 5. So how much will that be worth after 5 years? What do we think? I see a couple of answers coming through. Let's have a look. Pafunzo, Callan have got an answer. And the ladies put an answer in the chat. Let's see who we think is correct here. Okay, so I'm going to bring the answer up on the board here. Oh, that got a bit big a bit quickly. Hey, got a bit excited. So all I need to do is put those numbers all into the formula, and then I'm going to get this. And then the final answer is 48,000 Rand. So that's how much it is worth after starting life being worth 120,000. I want to know from you, based on the same question, how much depreciation has there been? How much money or how much value have we lost on this car? Remember, it's now worth 48. It started life as 120,000. So how much depreciation, how much loss of value has occurred? It's a slightly different question. So I'm not asking how much will it be worth. I'm asking how much money has it lost or how much has it depreciated? So I can see the answers flying through here. If it was once worth 120 and it's now worth 48, well, what's the difference? It's just going to be 72,000. So there's been a loss of 72,000 Rand in value through depreciation. Okay, that wasn't so bad. Now, the important word I want to point out is that it definitely said simple interest and it's depreciation. So it's losing value, but it's using the simple interest formula. Okay, let's have a look at another one. Ooh, so this one says a car worth 120,000 depreciates at a rate of 12% per annum, but it's on the reducing balance method. Now, the reducing balance method is another way, a synonym of saying compound depreciation. Okay, so what I have there is it's telling me the formula I must use is A is equal to P1 minus I to the N. I want to see, can you work out for me how much will this car be worth if I'm losing 12% using the compound depreciation or the reducing balance depreciation method? See if you can work that out. Write down what you think A is, what you think P is, what you think I is, what you think N is, and then use that to help you find that answer. I think I'm going to need to get my calculator out here. Let me go and find it while you work on that. Okay, so we start our life at 120,000. We know that my interest rate is 12% per annum, and the number of things is 5. So all I need to do is put 120,000, 1 minus 0.12, and that's going to be to the power of 5. What are we getting? I'll pull up my answer now. Are you all getting 63,327.83? All right. Now notice that there is a bit of a difference, and that's because with the compound depreciation, so say you lose a certain amount of money in year one. When you depreciate in year two, you depreciate on what's called the book value, right? So if you start off the car being worth 120,000, and then in the first year it loses, okay, well, let's even see, 120,000 times by 0.12. So in year one, we are going to lose 14,400 Rand. That's how much depreciation there is in year one. Now, in financial maths, there's this idea called the book value, and the book value is just going to be however much it was worth minus how much depreciation there has been. And in this case, the book value after 1 year, so 120,000 minus 14,400, after year one, the car is worth 105,600. Now, when I depreciated for the second year, I depreciated based on the 105,600 or the book value. And that's how it goes. And we do that for 5 years. And that's what the formula gets us. The formula gets us after 5 years, it's only the book value will be that. And it's different to the previous example, which was, what was the previous example's answer? It was worth 48,000. And so there's quite a big difference because of that different method. So what I want to ask you is, do you understand the difference between simple depreciation and reducing balance depreciation and how it has different formulas? Give me a thumbs up if you understand the difference. Give me a thumbs down if you do not understand the difference. Okay, then I think we are ready to continue our journey into the land of finance. Okay. So here is a question. It says, the value of a piece of machinery depreciates from 10,000 to 5,000. So it was worth 10,000 and went down to 5,000. It took place in 4 years. Then it says, what is the rate of depreciation correct in 2 decimal places if you use the straight line method? The straight line method is another way of saying simple depreciation. And then what is the correct rate of depreciation if I use the reducing balance or compound depreciation? So what I'm going to tell you for A is I will give you the formula like that for A, and I will give you the formula like this for B. Can you work out what is the rate of depreciation for each of these situations? And I'll give you one hint. Well, I'll give you a tip. Which value do you think we're solving for? Are we solving for the A, the P, the I, or the N? And if you're feeling generous, won't you help a classmate out and tell us what is the value that we're solving for in this question? When we say depreciation, I don't see a D in my formula. So if there's no D, what is the I? Well, I kind of gave it away. So, okay, Tandiwe Puvunzo, you've helped us out. We are going to be solving for this I value here. So, all you need to think about is what are the other values here, and then I want you to try and work that out for me. Let's do this. Let's do it. Make sure you've got your calculator with you. Give me a thumbs up if you agree with the way I started those questions. Okay, I'll give you more time to get the answers, and then you tell me in the chat when you. I'm gonna have a chocolate biscuit while I wait for you guys. This is a tasty biscuit. Okay. So, well, it was my birthday on the weekend, so I've got lots of biscuits to eat, so I have to eat them sometime. Okay. Oh, thank you. So, what we have here is that, and so we have a half equals 1 minus 4i. Then we are going to have, it's going to be minus a half equals minus 4i. And then basically we're going to get I is equal to, did we get 0.125? Thank you, Tandiwa. I appreciate that. Which is the same as saying 12.5% per annum. Now, the important bit is that this is depreciation. And so this will be a if you say depreciation, that's fine. It means negative. Some people like to use the plus formula as opposed to having the minus there. Then your answer will come out with a negative, and that's completely fine. It's just because it's a depreciation that'll come out negative. Because some teachers like to just say, use plus for all of them, and then your answer just comes out with a negative, which tells you depreciation. Okay, let's try and do this one. So this one over here, I bring this across. I've got 5,000 over 10,000 is 1 minus I. And this pesky to the power of 5 is making my life difficult. Can anybody help me? How do I undo a power of 5? What is the opposite of a power of 5? There's two ways of doing it. The one is to say, take the fifth root. So you say not the square root, the fifth root, but then what you do to the one side, you do to the other. So that's the one way of doing it. Or the other way of doing it is to raise both sides to the power of a fifth. This means the same thing. And if you do that, you're going to get 1 minus I, and then a half to the power of a fifth. And then, what am I going to get for my I value? Who can help me out? Are we getting 0.1294449, okay, and so on. And then if I write that as a percentage, it's going to be 12.94% per annum. So I'll just scroll out so you can all see that. Square, no, Naledi, not square, it's a fifth. So you undo the power of 5 with the fifth root. So not a square root. So you take a, if you were at this stage, okay, perfect. All right. Okay, give me a thumbs up if you're all feeling okay, or give me a score out of 10 for how you're feeling so far. 0 is no understanding. 5 is okay, but needs to improve. 10 is like, I've got this. Oh, I see. I made a mistake. Sorry, guys. I see what you're saying. This should be a power of 4, not a power of 5. So that was me being a human. So let me make that correction. So this should be, let me just redo that. Apologies. Thank you so much for picking that up. Luckily, it's not going to change too much. So this should be to the power of 4. And then what undoes that? It's going to be the power of a quarter. This is going to be a power of a quarter. Half to the power of a quarter equals 1 minus I. I equals 1 minus. So let me try that again one more time from the top. 1 minus, open bracket, 1 over 2 to the power of 1 over 4 equals, and now I'm getting, what am I going to get? I'm going to get 0.1591, which is 15.91% per annum depreciation. Everyone happy with that? Give me a thumbs up if you've made the correction. Fantastic. All right. Let us continue on our journey. I see lots of happy thumbs. So this is good news for all of us. So here is an exam question. You can see this. I want you to do 4.1 for me. Do 4.1. See if you can do that. Off you go. For 2 marks from a past exam. And if you are stuck, I would love a question. So I'm going to scan the chat. No problem, Kelo Bukhile. It's great to have you with us. And welcome to our new M class. We're like the BMWs. We're M class. The M series. Okay. So I want you to think about what formula should you be using. So it says, where's that keyword? Straight line method. The straight line method means the simple interest, which means it's going to be that formula. Now, let's see if you can work that one out. So in some ways, this isn't actually that bad. This is 145,000. Now, it's 1 minus. Now, the I is going to be 0.17 because of the 17. What's the N? Oh, it's going to be times by 5. So let's see. 145,000 times 1 minus 0.17 times 5. And I get 21,750. Really? Wow. So that's hardly worth anything. Pop-up question. How much depreciation has there been? How much depreciation has there been on this car? You've worked out how much it's worth now, but how much depreciation has there been? So how much loss of value has there been? So I go 145,000, which is how much it was worth originally. I subtract 21,750. So I went 145 minus 21,750, and that gives me 123,950. 250. So I have lost that amount of money through depreciation. And I see Callan, Naledi agrees, Tadiwe agrees, Amelia agrees. This is fantastic. Okay, give me a score out of 10. 10 is like you're feeling perfect. 0, you have no clue. 5, you sort of know what's going on, but you need a bit of an upgrade. Tell me how things are going in your mathematical world right now. Because remember, I can't see your face, and so I have to use these numbers to give me a sense of how you're feeling. Thank you so much. These numbers are so helpful. So it really allows me to be the best teacher I can be with these numbers coming through honestly. Let's do one more question, and then we're going to take a break. So it says, a company bought machinery costing 80,000 Rand using the reducing balance method. So what is that another way of saying? What's another way of saying the reducing balance method? So reducing balance is the same as saying compound depreciation. So you are going to have to use the formula that has this structure to help you. Now, I don't want to give you any more tips. I want you to do the rest by yourself. Calculate the rate of depreciation given that you're using the reducing balance method, which is basically saying use the compound interest formula, but just use it with a negative for depreciation. Okay, off you go. I would love some questions, but otherwise I'm going to assume that you are on your journey to discovery. So the machinery cost 80,000. So your starting value or your initial value is 80,000. The final value or the book value is 20,000. Book value is a fancy way of saying the value right now. So 20,000. The N is 5. So I think I should be setting up an equation that looks like that. And what you need to find me is you need to find me what that I is, because that's going to be my rate of depreciation. I'll give you a bit more time on that. So I think my first step is going to be to bring over this. This is reminding me of a question from earlier. So 20,000 over 80,000, that's the same. Now, I'm not going to make the same mistake I did earlier. So either I'll take the fifth root on both sides, or another way of doing that is just to do this. Raise both sides to the power of a fifth. Then what am I going to get? That's going to knock that out, and I get 1 minus I. Then if I bring the I to this side, I'm going to get 1 minus a quarter to the power of a fifth. And what are we getting for that? Help me in the chat. 1 minus fraction button, 1 over 4, close fraction, to the power of, open up a new fraction, 1 over 5 equals, and we get 0.2421, which is the same as 24.21% per annum. Now, what that means, because it's depreciation, is I'm losing 24.21% of value for every year that goes past. Give me a thumbs up if you followed that one, or give me a thumbs down if I went too quickly on that one. Or thumbs up if you followed it and you were okay. All right. Okay, we've been doing very, very well, but in order for our brains to hold this information, we need to give ourselves a break. So please, everyone, join me in standing up for a second. You have worked hard. You deserve a break. So let's just take 3 deep breaths. Breathe in. Breathe out. Breathe in. Breathe out. Breathe in. And one more, because you're worth it. Okay, so nice and loose now. Let's shake out your arms. Shake them out. Shake out this arm. Get it nice and loose. Shake out your legs. Okay, we shake those out. And then let us do some jumping jacks to get our heart rates pumping and the blood traveling through our bodies. So we're going to start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think I'm getting fitter because I didn't get so tired that time. How are you feeling at home? Are your hearts pumping? Are you also getting fitter? Is anybody getting fitter like me? I feel like my heart is adapting. Normally I'd be out of breath now. Okay. Let us continue our journey through this depreciation land. Okay. Let's have a look here. Okay, I like this one over here. This is a bit more interesting. I know there's a lot of words on the screen, but we will just have a look at it. So this is like a combo question. It combines 2 ideas together. So it says, a business buys machinery for 2.2 million rand. This piece of equipment loses value. It's calculated at 17.5% per annum on the reducing balance method. Question number 1 for you guys is work out the book value of that machinery after 4 years. So basically, it starts live being worth 2.2 million rand, or 2,200,000. We are using the reducing balance method what is that machinery going to be worth after 4 years? I want you to work that out for me. Thanks, Amelia. So we need to make sure we've got the correct formula. So let's just all check that you are using that formula. Now, what value is A and what value is P and all this stuff is important too. So we've got 220,000, 1 minus 0.175 to the power of 4, and that is going to give us an A value of something, which is actually going to be the book value. So what is that book value going to be? Okay. What are we getting? So we've got 2,200,000 times by 1 minus 0.175 to the power of 4, and I'm getting 1019150.8, I'll round off, 0.86. So it's gone from being worth 2,200,000 all the way down to this over here. And I see Naledi, Cullen, Tandiwe, Pafunzo, we're all over this. Fantastic. Okay, so we figured out how to work out the depreciation. Now the next question, it says, calculate what it will cost to replace the machinery after 4 years at an expected inflation rate of 6.5% per annum. Write your answer to the nearest rand. Now, what's important here is this is not about depreciation. We are not losing value. We're trying to go into the future. And something that cost 2,200,000 today, how much is that worth in the future, in 4 years' time, if the inflation rate is 6.5% per annum? I'll give you one tip to start with. The formula you are going to use to help you work out how much this 2,200,000 is worth in the future is this. But you need to do the rest for me now. It's like if your BMW costs 400,000 Rand today, I can promise you in 4 years' time, your BMW is not going to cost 400,000 anymore, because inflation compounds yearly, or it compounds over time. And so you need to get to a higher value in future. So see if you can figure out that one. Okay, how are we doing here? Let's have a look. How much is this machinery going to be worth in the future? So today is worth 2,200,000, but it's going to increase. Now I need to make sure that I don't mess up this fraction. So it's 0.065 to the power of 4. So what are we going to get in future? So I put 2,200,000 times open bracket 1 plus 0.065 close bracket to the power of 4, and I get 2,830,225.97. So it's gone from 2 million to 830,225, and I think that sounds pretty reasonable to me. Oh, Amelia, how can I help? What is your question? Can you hear me, Amelia? Or maybe that was just a supportive hand. Oh, no problem, Amelia. Not a problem at all. Okay, let us do another one because you guys are doing so well here. Feel like you've got that one. Okay, well, let's do one more. Let's do 8.1, and then I think we'll have to find, I think we've done depreciation, and then I'll go back to compound interest questions. Okay, let's do 8.1. See if you can do 8.1 all by yourself. I'm not going to say too much because I feel like I've probably said too much earlier today already. See if you can do the one in yellow. So first of all, are we going to get the correct thing here? It's straight line depreciation. Now, what is all the values that go away? So we know that this is 140,000. Now, what is the depreciation rate? Oh, it's 0.14. And then how many years is it for? It's for 4 years. So for me, the straight line thing is important because this means simple depreciation. So what are we going to get as our final value here? So if we pop this 140,000 times open bracket 1 minus 0.14 times 4 close brackets, we get 61,600. So that's how much the car is worth after 4 years. It's 61,600. Okay, we've done so well with depreciation. What I'm going to do now is I'm going to go back to interest quickly, and I'm going to just see how you guys do on some interest questions. All right. Let's see if we can find some interest questions here. No, not that one. Okay, let's finish with what I call a simple timeline question. So, last question for today. 7.3. Give me a score out of 10 how scary 7.3 looks, where 10 is very scary, 0 is like, that doesn't scare me, 5 is like, I'm just a little bit scared. How does 7.3 look to you? Okay. So in the land of financial maths, we have this thing called interest, where it's increasing in value, and depreciation, where it's decreasing in value. And that's what we spent quite a bit of time working on over the last while. In reality, when they ask you these questions, they don't say which one it is. You have to recognize. So let's look at 7.3. It says Sipo invested 30,000 for 6 years, and the investment earned interest at 12% per annum, compounded monthly. So there's a couple of things going on here. The one is it's an investment and it's earning interest, so it's increasing in value. So the formula that I use is going to have a plus in it. I also see that it's compounded monthly, and so I know that the formula that I'm going to be using is the compound growth formula, not the depreciation formula. There's no negative. Give me a thumbs up if you're okay with that part. Okay, now it says, for the first 2 years, I earn interest at that rate, but then it changes. It compounds over a different interval. Calculate the value of the investment at the end of 6 years. So, because there's interesting stuff happening, I'm going to make what's called a timeline. And on that timeline, I'm going to put T0 for the very beginning of life here. Now, if I look at the investment earned interest at 12% per annum compounded monthly, I can see that this question is not based around years, it's based around months, okay? Because it's basically, it's based around months. So even though it's 6 years in total, I would really like to know how many months are there in 6 years? Can you tell me? How many months are there in? There are 72. So on my timeline, I'm going to put T72. Now, if I look at when funky things happened, for the first 2 years, it was compounded monthly at a certain interest rate. Now, how much is 2 years in months? What is 2 years in months? It's 24. So you know what? On my timeline, I'm going to put T24. Okay, so if I want to describe this question, the first part of it is this part over here. And I'm going to say that the interest rate is 0.12, but I have a problem. I can't just say 0.12 because it's compounded monthly. So I need to take the 0.12 and divide it by 12, so I have a monthly interest rate of 1%. Give me a thumbs up if you followed what I'm saying there with the black writing, where I said it's 12% per annum, but it's compounded monthly. It means it's every month. So that's why I divide this by 12. Okay, now, for the second part, it doesn't stay the same. I'm going to say the interest rate is, what is it? Oh, it's 0.108. But now I can't divide it by 12 anymore. What do I need to divide it by? Well, it says semi-annually, so that means it's 2 half years. So I divide it by 2. Now, I haven't actually started the question, but what I've done is I've set out a timeline that tells me, look, the first 2 years, which is the same as 24 months, has that interest rate. The next part, the next however many months to go from here to here, is at this interest rate. I know what formula I have. So what I'm going to do is I'm going to write plus 30,000, which is how much money I'm starting out with. It has got to grow from here all the way to there. In fact, let me use black because it's the color I was using. It has to grow all the way to there, and then it has to grow even more. Can you tell me how much money I've got at that point, at T24? Can you work that out for me? So I've got my timeline here. I've got 30,000. It has to grow. Can you work out how much money I have in the bank after 2 years? So let's think about how would I work this out. I know it would be a 30,000 1 plus 0.12 over 12. What's going to be the n value over there? I think it has to be 24 months because it's traveled from T0 to 24. So it's 24 months. So if I put that in my calculator, 30,000 times 1 plus 0.12 over 12 to the power of 24, and I get 38,092. Okay, everyone. So at this point, I've got 38,092, but the problem is this has to keep growing for how many more months? How many more months does it have to keep growing by to get to the end of 6 years? Well, it's not 72 because I've already used up 24. So I go 72 minus 24 and I get 48. Give me a thumbs up if you're okay with the 48. All right. Okay, you're not. Okay. Think about this. If the whole thing is 6 years, from T0 to T72 is 6 years. I grew from 30,000 and I grew to T24 and I've got this much, which was 38,092. Now this bit here, I'll sort of put it in one box. That bit there has to keep growing, and it's going to keep growing, okay, by that interest rate. But I'm not going to put months there. It is 48 months or 4 years. What I have to do is put how many half years are there. So this was 2 years, that was 4 years. How many half years are there going to be between here and here? Because remember, our interest rate is in halves. CM Tanda, the reason we divide this by 2 is that in the question, it said compounded semi-annually. So semi-annually means twice a year. That's why I'm dividing by 2. But now the tricky bit is how many 6-month periods fit in that part there. So in the first year, it'll be 2. In the next year, it will be 2 more, then 2 more. How many half years fit into 4 years? I think that this thing over here is going to be 8. because 4 years divided into halves gives me 8. Now that was quite tough, and this was just I'm going to do a whole lesson on timelines in future. Today was just a warm-up, but I just wanted to give you a bit of a renewed. Don't worry if I've lost you, it's not the end of the world. Think of it this way. Here's the timeline. If I go from T24 to T72, that is 48, that is 4 years or 48 months, right? 48 months. Or we could say it is the same as 4 years. How many 6-month periods are there in 4 years? Well, it's just going to be 4 times 2, which is 8. That's why this thing over here is a 8. Now, just to show you what happened here, we're going to finish with this. For the first 2 years, it grew, it compounded monthly. That's why it's 24, because there's 24 months in the first 2 years. Then it compounded every half a year, and that's why there's an 8 there. Can you type this in your calculator and give me a final amount that it's worth at the end? Can you give me a final amount that it's worth? I'm going to put this in my calculator now with you. So 30,000 times open bracket 1 plus fraction 0.12 over 12 close bracket to the power of 24, bring it down, times open bracket 1 plus new fraction 0.108 over 2, move to the end, close bracket to the power of 8, and what am I going to get? I get 58,017.51. So, just to go back on what we did today, we covered the idea of depreciation, which most of you seemed pretty good with. And then at the very end, I honestly went pretty hardcore. I'm not going to lie to you. So I do want you to re-watch this last 10 minutes on the recording. But this was the beginnings of what we call timelines. And next week, I'm going to come back and do some proper building up to timeline questions. But today was just the beginnings of getting going. Okay. Now, everyone, it is officially the end of the lesson, but we have an extra bonus part of the lesson that you don't have to stay for, but I just want to show you the idea behind it. So I'm just going to look into the question. Okay, there are no questions from students in the Google form that I set up, but I'm just going to put that link in case anybody has a question that they would like to share. So in the chat in the Google Meet, there is a Google form that if you have a question that you did in class today that you want to ask me about, you just need to put that question into that Google form. But I'm simply going to, for those who would like to stay around, I'm going to go through this question over here, which is from last week's quiz, but a lot of people got it wrong. Okay? And so I want to go through that now. So give me a thumbs up if you're okay with me going through this now. Okay, fantastic. No worry, Bukle. Enjoy maths tomorrow. I hope it goes well. In future weeks, we'll have more answers to put question-ins. Okay, so it says 5,500 is invested for a period of 4 years in a savings account. So in some ways, if you imagine like in the beginning and the end, 4 years. For the first year, the investment grows at a simple interest rate of 11% per annum. So what is the simple interest formula? It's that. Then for the rest of the period, it grows using the compound interest formula and it's compounded quarterly. So what I'm going to do first is I'm going to use 5,500 go 1 plus 0.11 times 4. And that is going to get how much I have in the account at the end of the first year. 1 plus 0.11 times 4, close brackets. And I get 7,920. Is everybody with me so far? Thumbs up if you're with me so far. Okay, now for the next part, I need to switch to the compound growth formula. So 7,920, 1 plus, but here's the tricky bit. It's 12.5% per annum, but it's compounded quarterly. So I need to divide this by something. What am I going to divide the 0.125 by? 4. Yes. Perfect. But now hold on. I've used up 1 year. It has to grow for 4 years. So I've only got 3 years left. But the problem I have, everyone, is, okay, so if you imagine this is T0 and this is T4 and we're working in years, this is T1. So we've now got 3 more years to go. But in this 3-year period, right, the interest rate is broken up into quarters. So what I need to now know is how many quarters are there in this 3-year period? Can anybody tell me how many quarters are there in 3 years? Well, if there's 4 per year and there's 3 years left, it must just be 3 times 4, which is 12. So what I need to do is put a 12 over here. What do you get if you put this into your calculator? So you take this and you grow it like that. Let's see. 7,920 times 1 plus 0.125 over 4, close bracket, to the power of 12. And I get 11,000. Did everybody get that? 11,457.57. So I think there's a mistake in the question because I don't see the answer here. Everybody else see that? The honest truth is that there was a mistake in the question that I need to correct. Hi, Callum, can you go ahead and ask a question?
Hi, sir.
How's it going?
Sir, for the simple interest, I think the mistake is by the 4 because you said 4 years instead of 1 year for the first
Ooh,
year.
goodness gracious. Did everybody catch that? Oh my goodness. That is my problem. Thank you so much, Helen. Well done. You know what's potting here. 1 plus 0.11 times 1. And then I get 6,105. Let's try this again. And maybe the question wasn't wrong. Maybe Mr. S was just having a moment. Let's check. 6,105 times 1 plus 0.125 over 4 to the power of 12. I get 8831. Ooh, it was, there we go, 8831.88, which means the correct answer is that one there. Okay, sometimes we learn more from our mistakes than we do from our successes. So give me a thumbs up if you guys, okay, I think everyone is okay with that. All right, everyone, because today was a change, I'm going to call it there for tonight. But in future, if you have questions that you would like me to engage with, I will gladly engage with them until 7 o'clock. So you've got, so in future, that is available to you, but at the same time, we don't have to use it. And I understand an hour is a long time, so to stay for longer, not everybody would maybe want to, but that is an option that is available to you. So just give me a happy face or a thumbs up if you understand what I mean about question time. Okay. Yes, Pabelelo, you can ask about any question you like. So if you, let me just show you quickly what I mean in terms of how do I actually get this question to me.